So from last time, we talked about hailstone, and did anyone do it? Raise your hand high if you did it. Sort of, like halfway. No. Okay. So not a lot of you guys did it. So we're just gonna go over this solution iterative stuff.
All right, so you, if you were waiting here, you could have worked on the hailstone problem, and what we're gonna do now is just go over the we're gonna go over the iterative solution for hailstone. So if you go and open up Sublime and open a new file and save it, let's save it as bb2 for Beyond Blocks 2 and .py for Python. So to define a function, we start with a def statement, right?
Make it bigger.
All right, so we define our function is called hailstone, and it takes in one variable n. So the instructions here say if n is even, divide by 2. If n is odd, multiply n by 3 and add 1. And then you repeat it until n is 1, and then you return done and print n for each iteration. So we could use a while loop, and we could say while n does not equal 1, if n mod 2 equals 0, this tells us if n is even, then we can first, before that, we should print our n. Okay, and then if n is even, then we set n to n divided by 2, else okay, so else. Oh, so this is, yeah, we didn't go over else.
This is like a syntax for Python. So you know in Snap you only have if and else. So in Python, if you want to have more than one if cases, you would have to have if and then else and then if again and then else and then if again, right? In Python, you can just directly say elif, and then it will just create like a new else if statement for you. That's just like a syntax for Python.
We could also just, since we only have two outcomes, if n is even or odd, we could say if this is even, do this, and then we could just unindent here and set n equal to n times 2 plus 1.
You need to return it.
Right. And then when the loop finishes and n does become 1, we should print our n again, because n won't be printed when n is 1. So we'll print n and then return done. Save it.
How do we save this? Oh, just press Control S. I think you need an elif statement for this one.
Are you sure?
Yeah, because it's gonna do this and this. It's gonna do it twice.
Right.
So does everyone get that? If you don't get it, raise your hand. I can explain it furthermore.
Can we run this?
Yeah. Okay. No? Okay. Let me. So I'm just gonna record my terminal real quick. Okay, now you can see desktop.
Excuse me, could you go over what you're doing again? Like how
Oh.
to call that desktop?
Right. Do you want to do that?
Like just really quickly.
I'll do it. Yeah, fine. Okay, so so are you guys in your desktop directory? If okay, so if you're not, you're starting like in the beginning, right? So you just type in cd desktop or whatever you store your file is, and then you should be in your desktop directory. If you're not, you should raise your hand. Okay, we're on the same page. So to run the Python file, we can say python3-i. That means it's in interpreter mode, and then you can run your file, which in this case is bb2.py. Did we do that? All right. So when you enter that, you get this 3 arrow screen. So this means that this indicates that you're in Python. So in order to run the function, you just directly type in the function. And let's test with number 11. See what happens. Does that look right? Yep. Does that look right?
Yeah, that's good.
I hope it is.
I mean, it has decimals because we didn't for div it, but whatever. It should be good.
Yeah, looks right. Any questions? You can do the recursive one.
Okay.
So just press Control Alt and arrow keys to switch the screen.
Okay.
Yeah. So. Yeah. You have any question?
Okay. Do you have a question? Okay. Does anyone have a question that we could answer up here? Control left and right.
Control Alt. Yeah. So I think you're on the top screen already. I think that's where. Yeah. Something like this.
Oh, I see.
Just let it go.
Yes.
Run the Python file.
How to run the Python file?
Yeah.
So you go to your terminal,
Yeah.
and then
Are you in? Where did you save your file?
In the folder. I'm inside the directory of the folder.
Okay.
Like the
Then
unlocked.
directly, do you have Python 3 installed or Python 2? Python 3, right? So directly type Python 3-i means that it's gonna go into interpreter mode after you run the file and then run your file name. Yep.
it should be like that. If it doesn't work for 3, try just regular Python.
Okay.
Yeah.
Is it working?
No, valid syntax.
Yeah. So
I tried to just Python. I think I have.
can you go back to the code real quick?
We have 2 minutes.
So if you look at the indentation, the print statement is directly under the while statement, and yours is indented below the while statement. So this means that it's printing it under the while statement.
Yes. There's a print here because for each n we want to print it. So for each iteration in the loop, the first thing we want to do is just print n before we change it, because once we change it, then it's different, right? Does that make sense? Okay. This so mod is the syntax for mod is a %. Yeah. No, this is percent. Divide is this. A slash. Okay, so now we'd like to move on to writing this function, but in a different way. So you guys have learned about, writing things iteratively, and then there's another way you can write something. Recursively, right? So do you think we can write this recursively?
Yes.
I don't see
I
why
think
not,
so.
right? Okay, so let's define the hailstone recursively. It should behave the same way. So we can define it, and we'll just define it as rec for recursive, and then an h. So what's the first thing we need in a recursive function?
Base case, right?
Yeah.
What's our base case? What was that? Yep. What do you do? Okay, but in Snap is report. What do you do in Python?
It's print n.
Report and print. See, that's okay. So we have so that's a big difference between report and print. Print, it will print it out, but it won't terminate the program.
Oh, print n.
Report will report it out, and it will immediately terminate the program after it reports it out, right?
Yeah.
Report is equivalent to return in Python.
Okay.
Yeah.
So print and return.
Huh?
Would you print and return?
We should do
Well,
both.
what does return do?
It ends the program.
Huh?
It ends the program.
Yeah, it ends, but like if you return 3, what does it do?
I'm not sure.
It prints 3 and then it terminates, right?
Okay. You just do return.
Yeah, you just do return. Yeah.
Okay.
All right,
So
so
you don't need a print. Okay.
So for this function, the way we want it written, we want to print n for each n and return done. So if we just stick in n to recursive hailstone, and it's 1, then we can just print n, because n is 1, and then we can return done. That looks like a good base case, right? Okay, so then else, we have our recursive call, right? And how many recursive calls do you think we need for this function? 2?
Right.
Okay, so what's our first recursive call? If n is even, right? So we can say if n mod 2 is 0, this checks if it's even, then we want to print n. Actually, we could probably make this more efficient if we just print n at the top.
Yeah.
Why? Because remember in our iterative case, the first thing we did was print n. So before we get to our if and else, we can just print n.
And then it'll update n as it goes along, and then
Okay, so if n is even, then we can return our recursive function again. And instead of putting n in there, we need to put n divided by 2. This is where we modify our input to get closer to the base case. Does this make sense? So it's just a regular recursive function. Okay, so else, if n is odd, then we can return recursive h. And instead of putting n in there, we could put n times 3 plus 1.
you think that will work?
Okay, so let's save it, and then let's run it in our interpreter. So first, we had just our regular hailstone function, and let's stick in 11, and we get this list of outputs and done. And if we put our new recursive h of 11, we should get the same thing. And we do. Does anyone have any questions about this?
Can you go back to the Sublime text?
Sure.
Recursive solution? Just-
Sorry.
Who has any questions? Yeah.
Why did we put adding up 3 to get the
Oh.
N
okay.
mod 3? Well,
Wait. What?
is 6 mod 3 0? So that, yeah, that it's good to think about that, but for this case, that wouldn't work. I think it's easier to just check if it's even, and then if it's not, just treat it as if it's odd. Yeah.
So what's on the question? Just repeat so that we can straight. All right, so we're all set and ready to go for our next topic. Yes? All right. You guys sounds a little bit like tired. You guys are hungover or what? Look more lively. All right, let's do strings. Okay. So from last time we touched a little bit about strings, but not too much in depth about strings. So what's special about strings is that it's you can iterate through like this. You can iterate through every single letter of that string. And then there's also other methods for string you can do. For example, you can add two strings together. So like if double A add double A, you get quadruplet A. And you can multiply strings by a certain number, and it will multiply that string by that many times, and it'll output everything into one single string. And then you can also like grab a portion of the string using this notation. So this is called slicing. So you're telling the computer, okay, I want from index of 1 to 4, because this notation means that 5 is exclusive, right? So it's 1 to 4. So if you count this, you get 1, 2, 3, 4, right? Because everything in Python starts at 0. So this is 0, 1, 2, 3, 4. So you'll get LO. Okay? And also, when you print a string, when you print it, it won't include the quotation marks around it. But if you directly call it, it'll tell you that it is a string, indicating that, with the quotation marks around it, and it's just indicating that this is a string. Okay? Also, there's a function called length. Length is, it checks how long the string is. So in this example, this high is 2. So if you print length of 2, length of high, you get 2. And then there's also count. It counts how many R's there are in this string. So if you go back to the last slide, there's only one R in this string. So it should return 1. And the index gives you whatever place it's in. So in this case, E, it's in index 1, right? So if you say R.index of E, it will return 1. It's just indicating that E is at the position of 1. Okay? Anyone have any questions? Yep.
Are count and length interchangeable then?
Count and length are in. What do you mean by that?
Like, it's good because wouldn't length and count give you the same value for? Oh,
Huh? What?
Certain number of R's.
never mind.
Oh.
No, the answer is no. They're not interchangeable
Okay,
because
thank
count counts how many times R shows up.
Oh, that's right.
Yeah.
Length is how many there
Okay.
like total characters.
All right.
Yeah,
All right,
yeah.
Thank you.
Okay. So yeah.
If say there's like two L's like in hello, and you do the index, does it show? Does it say like?
Oh, okay. So let's see what it does. So let's say we have the string called hello world. So if you count word dot count, what do you want to count?
No, index.
Index. Okay. index L, what do you think that will return? Huh? 2, right? Why would it return 2? Yeah. So by default, the index function will count the first occurrence it sees. So in this case, the first occurrence it sees is at index 2. So it would just directly print out 2 and like terminates everything else. Okay? Alright. So I have an exercise for you guys. Let's do the so in this session we're gonna do things a little bit differently. We're gonna have two exercises. One is a bit easier than the other. So if you can finish this early, you can go ahead and do this one. So you can do this one first. Give you like 3 minutes.
So, okay, you did save it on your desktop. Let's exit out. Oh, no.
Who has any questions in regards to what they want, what they need to do for this one? If you don't get the instructions.
Exit, yeah.
Everyone got it?
Looks like you're not your desktop right now.
All right. Yep.
What does it mean by like has to be in these two?
So if you pass in like just A, it will just like
Now you're
you don't return anything else. So the length of the string has to be at least 2.
space dash I.
Yeah? Okay.
Interactive space. Yeah, it'll open your file interactive. Now you space and then your file name is eb2.py. And that should be and that didn't help you open that. What it's telling you here is that there's an error in your code that you open that properly. So if you want to fix the error, you can just fix it, save, and then exit out of this and it'll come up again.
Yeah.
Can you go back to the
The
Like whatever.
oh, this one?
Yeah.
Oh, I see. Yes, he's in the Python interpreter just like this. So if you want actually want to run these functions, type in else code or something like that.
Also, you don't need to include this print statement. You can just directly call length and it'll just return 2.
An error. It won't run.
Yeah.
And I can tell you your error right now. It's a line of syntax. Not
What's
right.
index again?
Yeah,
So index, basically, index, it just tells you what position it's in. So what is the index of L in this case?
3.
3, right? What is the index of W?
the exit there.
6.
Yeah, so that's what it is, yeah.
Isn't it 2 files?
L, this one?
Yeah, it starts from 0, you said, right?
Yeah, 0, 1, 2, yeah.
Yeah, 2.
Yeah, it's 2.
Oh.
Wait, did I say 3?
Yeah.
Oh, sorry. You guys almost done with this one? Who's done? Raise your hand. One person. You guys want me to go over it together? Yes? Okay. Alright, let's do this. So, we define our function. What was the what was the name of it? Extra n, right? And takes in some sort of string. So what do you think will be our first condition? Remember, it says that the length of the string has to be greater than 2. I mean, greater than or equal to 2. So what do you think is our first if condition? If length of the string, right, is greater or equal to 2, because it has to be at least 2, right? What do you do?
In that case, we would want the string.
Remember, what does the function do? It takes the last 2 string of that of this, right? It takes the last 2 letter of this, and it multiplies it by how many? 3, right? So how do you take the last 2 letter of that string? Length of string minus 2 length of string minus, what do I minus, guys? Huh? Are you sure it's 1? It's exclusive, remember? So do we even need to minus anything? No, right? Okay. So after that, what do you want to do with this whole thing? Yep. So return that multiply by 3. You think that'll work? Probably? Okay, let's try it. So let's open our interpreter. Extra n of a, b. Hey, look, it works. Let's try hello. Yep. So far, so good? Yeah. Oh. Anyone have any questions on this?
You moved the code over?
Yeah.
Okay, never mind. Go back to the
To where?
sublime.
Oh. Huh?
Sublime.
Oh. Yeah. You have a question?
Wait, it says return str and then brackets like.
Yeah. So I'm gonna just make this.
Yeah, I don't really get it.
Okay. So remember this? This is slicing. Oops. So we say from 1 to 5, it takes this chunk of the string, right? Right? So in this part, this is the same notation. So this just say length of string minus 2. That's the chunk of the string where it is the first occurrence of the last 2, right? So it's from, so if you have like a length of 5, length of string would give you 5, minus 2 is 3. So that's at index 3, right? So from 3 to the length of the string, which is 5. But the 5 is exclusive. So it's just 3 to 4, right? And then you multiply that by 3. Right? Okay. Everyone understood that? All right, good. So we're going to move on because we don't have much time. Has anyone got a chance to do this? How do you think we can do this without even trying to do it by hand? Just like conceptually, how would you do this? Yep.
Oh, this is not out there.
Huh?
Return second string plus first string. Plus second string.
So are we always assuming that the second one is shorter than the first one? And how about in this case? This one is longer than the second one, right?
Oh, sorry, I didn't see that problem. That's why it was just.
You can have it if
You can use the if else.
Yeah. So what will be our first if statement?
length A is greater than B.
Yeah, if length of A greater than B, what do we return?
String of A plus string.
So we return A plus B plus A, right? And in the else case, what we return the opposite, right? Yeah. So that's how you would do this one.
But it's shorter, so it's BAB.
Yeah, BAB. Anyone have any questions on this? All right, we're gonna move on. So we're gonna go more in depth with strings. So like we said, there's this notation, meaning that word of start to end exclusive. So items start through n minus 1. This is what that means. And if you don't put anything in the end, it will just return from start to the end of the string. Right? Anyone have any questions on that? And this is the same. So if you don't put anything in the front, it will return from the beginning of the string until where you indicate it to stop. Minus 1, obviously. Yeah. And if you don't put anything in between of these two, it will just copy the whole string. Let's do that in interpreter. So let's say we have word equals beyond blocks 2. So word of 2 to 5. What do you think that will return? E-Y-O-N?
No, Y-O-N-D.
Y-O-N-D? And everyone agree with that? Yeah. Well, oh, there's no D because 5 is exclusive, right? How about 2, 3 to that?
On blocks.
Yeah. How about from that to say 1, 2, 3, 4, 5, 6. What do you think that will return? Beyond, right? How about I'm gonna trip you up a little bit. Let's say -2 to 5. What do you think that will return?
Yeah, or would that be an error?
Would it be an error? Huh? Wait, what? So you mean returns nothing?
It returns a quotation.
Yeah, so an empty string, right? Okay. So anyone else have any other inputs? All right. Good job. How about -3 to the n? What do you think that would return? Why? Anyone knows why? Yeah, so -3, right? Where's -3 in this string? So 0, -1, -2, -3, right? So it starts here. And then you tell them that print the whole thing after that part. So it's s blank 2. That's why it's s blank 2. Yep? Okay? So we're gonna move on. That's enough for that. Yeah. Oh, how about this? So let's say I have word of 1,000 to 1,001. What do you think that will return? Would it error out? Huh? Would it error? Who thinks it's error? Raise your hand. Who thinks it will return an empty string? And the rest of you kind of like, okay, I'm in between.
Wouldn't it be empty because there's no like anything between those?
Okay, yeah, that's correct. So what this is telling Python is that so basically whatever's after this is like nothing. So if you tell it to print nothing, it will print nothing because this index is just saying there's nothing after this. So if there's nothing, it will print nothing. Okay? All right. There's also this thing called random generator. So you need to import it in from the Python library. So to import stuff in Python, the keyword is from, and then whatever library it is. So usually to know what library you want to import, you can Google it. So in this case, I already told you guys it's random. So you can import from random, import random. And then if you call this function random, spell wrong. It will did I spell it wrong?
Rand it, import rand it.
Oh, oopsies. From random, import rand int. Okay, so rand int in range of, yeah, so you can say pick any random number from the range of 0 to 100 and it will return 41. So every single time it will return like a random number to you. Okay?
Are the bounds inclusive or exclusive?
It's exclusive. I think almost everything in Python is exclusive in that notation.
So that'd be 1 to 99.
Yep. All right. The reason why I brought that up is
No, it's 0 to.
yeah. So the reason why I brought that up is because I want you guys to do this problem. Gonna give you like around 3 minutes to do this.
This is all, the first one is always inclusive, the second one is always exclusive. Okay, now that's good. It's actually inclusive.
Anyone have any ideas how to do this? Yeah. How would you do this?
So if phrase does not contain like string, tell me please, then report or return, you must learn to say please.
Uh-huh.
Then else, return other things. Why do you get that part?
So it returns a random number, right? So how do you generate a random number?
Then return random from 0 to whatever you want.
Yeah, okay. All right, fair enough. Let's do it. So define, tell me, phrase. So what is our first if condition in code?
If
Phrase.
does not contains like exclamation point equal sign.
Okay.
Tell me please.
Tell me, please.
Return, return the string. You have to learn to say please.
Yep. Must learn to say please. So also, a quick aside note, the biggest difference between the single quote notation and a double quote notation is that if you want to use a single quote notation within the double quote notation, you would have to distinguish Python with that. So like in this case, it will return this without the quote around it, but you still want the single quote around the word please. That's why you would have the two notations. Okay? Else, what do we return?
Rand int from 0 to whatever.
So, but what do we need to do first? Is this function defined?
Oh, no.
No, what do we do?
Define it in the beginning.
Huh?
Define it in the beginning.
Oh, we can import it, right?
Oh, right.
From random, import rand int. And that's how you would import stuff. You always put it in the top of the file. Okay? So let's run this code. So tell me. What do you think that will return?
You must learn to please.
Yeah. How about kick me?
Same thing.
Yeah. How about tell me, please? Yeah. Good job, guys.
How do you import it into the Sublime text editor? How do you import it into text editor?
Import what?
The random.
Oh. So on the top of your file, You put from random import ran int.
Okay.
Yeah, and you just save the file and run it. Yeah.
How do you make it say no?
Oh, okay. We can make it say no. So how do you make it say no? Elif what? Who has an idea? So in this case, it says, kick me, but with the word please in there. Okay? So what do we need to check? Huh?
Whether it has please in it.
Okay. After it has please in it, what else do we have to check?
And we make sure it doesn't say tell me.
Yeah, okay. How do we do that in code? Huh? Okay, if phrase equals, no, if phrase contains, I think there's a method called contains, is there?
We'll find out.
Okay, we'll find out. Let's see. Contains, please. And oh shoot.
That works too, but.
Too much Java for me.
No, that works too.
Phrase dot contains
Yeah, and this.
what? Tell me, right? Wait. Return. No. See, would that work?
Ampersand.
What else? What are we missing here? So what does this condition check? It checks if it contains please and contains tell me. But what do we want to do? You want to check if it contains please and not tell me, right?
So contains actually doesn't work.
Oh, so what is
We
it?
just say is in English. Why are we
Oh.
coding when we could just write it in English?
All right, so in English, it's is in.
So if you want to say is please in, if please is in phrase.
Oh, okay, I see.
Yeah.
Elif, please, in, phrase,
And yeah.
and not
In. Yep.
tell me, in, phrase. We return no.
There's two spaces though, tell me.
Oh. Okay. Would this work?
When
Let's
in
try
doubt,
it.
just type English. Python actually might work.
Python is English, yep.
Nope.
Oh, I think I have my semicolon. Oh, duh. Alright, tell me, kick me, please. Well, that didn't work. So what went wrong?
It should be tell me not. Yeah.
Is it please in?
Hmm?
When you put the else in the correct spot, split the other if else. Is that okay?
So you're saying you put this whole line on top instead?
Yeah.
Okay.
But I don't know, somewhere else.
You need to indent the else if statement to within the if.
No, in this particular, so the syntax in Python is that you don't need to indent it. You can just directly put it there. Okay, we can just say this.
No, it's not.
Would that work? All right, let's try it. Huh?
Go back to the code. Does it work?
I think it's phrase does not equal tell me please. It should be contains.
Phrase not equal to tell me please.
Oh, okay. All right, I know why. So it checks this condition, right?
Yes.
So it checks that first, and this condition satisfies it. That's why it returns this. Does this condition satisfy this condition? It satisfies it, right? So it immediately returns this, and it terminates the program, right? So what do we need to do? Move this whole thing up, right? Okay? Tell me, kick me, please. Yep.
Does everyone get that?
Does everyone get that?
Song,
I see some confused. Yeah, maybe we can go.
do you
with
want
that.
to tell us how you figured that out?
Yep.
All right. So we know that the return statement returns the string, and then after that it terminates the program, right? So this is our code before. Let me move it back. This was our code before. So let's say you have like tell me and then kick me please. So would this string satisfy this condition?
Yeah, it's not tell me please.
Yeah. So immediately it'll return this string, and we know that return immediately terminates the program after return it. So it never hits this clause or this clause, right?
Yeah, so pretty much the first, what you want to do is if you have a whole bunch of if-else cases, you want to have the most general one at the very end. So because that first one is Q general, like we don't really want to check that first. We want to check a more narrower one first and then have the more general ones later.
Yeah.
Because the first one's like binary. Either it's tell me please or it's not. And if it's not, then it's just going to say you must learn to say please after.
Okay? Yeah.
I know Samir said that we should use is in. Is there any difference between is in and in?
Is there one?
Does isn't work?
Let's try it.
I'm not sure. I think I've used is in the past, but I'm not sure.
Okay.
But we could just try it, yeah.
This
For
is
me-
literally English.
Yeah, this is what I do. Like, say, if I'm not sure, I'll just try it, and then we'll know right away. So,
Alright.
All right, we're gonna move this back.
so that might be an optional thing.
Oh,
It
if-
just makes it more readable, and it might be good for style. Yeah,
That's it.
let's try it.
It doesn't
No,
work.
It doesn't work.
Okay.
Okay. Maybe that's another language.
But you can say, 1 is 1. That'll return true.
So you can replace equal with is then. I
Yeah.
think that's what it's saying. So instead of saying equals equals, you could put in is.
I see.
Yeah.
Is just check if it's.
Equal,
Never mind.
yeah.
Yeah.
Good
All right.
question. Yeah.
Good question. Yep. So this works, we know. That works, okay? All right, let's move on. Also, so with strings, we have replace method. So the replace will replace whatever the string you indicated to replace with another string. So in this case, we have a variable called intro, and it says, hello, my name is Song. So if you wanted to replace Song with something, and after that, it'll return this. So it replaced Song with Shabba Ding Dong. Yeah. So if you want to replace with, if you want to replace A in the word replace with B, it return replace, something like that. Okay? Anyone have any questions? All right. So this, we already know the in and split. All right, split. I think you can start by talking about lists. Yeah, because this is where it like introduced into lists.
Okay, if I use the interpreter.
We gotta get to lists.
Yeah.
Hey, if I use the interpreter, how do I type on how do I put the interpreter?
You press Control Alt and arrow keys, and you just browse through it. It's somewhere in there. Yeah, we are doing this. Yeah. So
Okay.
just quickly move along to
But even
this.
for lists, you might have to skip some of your examples. Because we have about an hour left for everything. record if I can select that.
Okay. So you guys have used lists extensively in Snap, and so interacting with lists in Python is pretty similar. How you indicate a list is you're going to use brackets. So for example, it would look something like this. So if we type that in, that's going to return a list. And because there's brackets, Python knows that you want to look at it as a list. Another way you can do it is, so we can set that equal to a variable if we want to alter it. Okay, so now we've set a variable equal to that list. And a bit earlier, we were talking about identity using is. So for example, if we set y equal to x, and we do x is y, that's going to return true. So earlier we had mentioned that you can replace a double equal sign with is, but if you set y equals to the same list, 5, and set y is x, that's going to return false. So in this case, you can see you can't actually replace a double equal sign with is, because when you do the double equal sign, that's going to, when you do is, it's going to evaluate both of those. So it's not going to, or sorry, when you do double equal sign, it's going to evaluate both of them. So if you do y double equals, sorry. So they both evaluate to the same thing, but they're not actually the same thing. So is checks for identity. So I just wanted to clarify that real quick. So now moving on to lists. In Snaps, a couple things that we did was we added items to list. We wanted to return a specific item to the list, and there are a lot of different commands for this. So one thing, we can manipulate it the same way we use strings if we want to call a specific item. So if we want to call item 1 of the list, we can do the same thing we did with strings, where we look at y, and then we call item 1 of the list. But remember, in Python, we start with 0, so we're going to call 0.
Did you explain again why x is 1 but y is not x?
Okay.
Yeah, okay, so when you do the double equal sign, what it's going to do is it's going to evaluate both of them, and they both evaluate to the same thing because we set it equal to each other.
Yeah.
So they evaluate to the same thing, so that's why they are equal. But is doesn't just evaluate it, it checks if it's the same item. It checks the identity of both of the functions. So right now, so we set, here you see that we set y equal to this list, and we set x equal to this list. So they're set equal to the same thing, but they're still different lists, right? So if we change to x,
Oh, so you put in like y equals x in the second one, then you put y as x.
yeah, so then it would be set equal to the same list.
Everyone got
Does
that?
everyone get that? Like, is checks for identity equality, like to see if they're the actual same object, whereas the double equals is content equality. So like, for instance, if my friend and I both have Toyota Camrys, then double equals would work because they're both Toyota Camrys, but my Toyota Camry is not his, too. He is his own. Does that make sense?
So
Yeah.
Does that mean that if you have some function that calls y and y equals x, then like it'll literally replace y with whatever x is?
Yeah, that's one way to think about it. So every change that you make to y will also change whatever x is equal to. Yeah. Yeah, that's a good way to think about it. So right here, this is how you call item x of list. So we can change what item we want to call. We can call item 2, and that'll just return whatever index, whatever value is associated with that index. And then we can also do 2 to 4, like we did with strings, and that'll return multiple values. And we can also change our list. So if we wanted to delete an item or if we wanted to add an item, there are a lot of different commands for this. And one good reference tool is, okay, if you go to, do you have internet open?
Internet?
Yeah, like Chrome.
Oh. Oh, well, we can exit out of this and we can.
Okay, so if you type in Python docs and then just search list. So Python docs has basically compiles all the different Python commands. So if you're lost at any point or if you want to look up how to do something, this is a really good tool. So remember, we said Google is always your best friend when it comes to programming. And so even like for us, even though we have learned Python, there are a lot of times where you forget to do one simple thing. So this is a good resource to do that. So if we click on that first link, it shows you all the different commands and it has a brief explanation. So if at any point, if you do forget one of the commands, you can just look it up. And so we can try a couple of these in our interpreter. The first one is append. Append, basically what it does is it adds an item to a list.
To the end of the list.
Yeah. You're right.
To the right.
Sorry. Oh, I see.
Yeah.
Okay. So our list Y, if we want to append an item, let's say we want to append 1. Now if we check what Y is equal to, there's a 1 at the end. Similarly, if we
Does it matter what kind of bracket you use?
Yes, it
yeah,
does.
so because we're calling it similar to a function, you're gonna, so when you use brackets, it's always for defining a list, and so, or calling an index, for example, but for this, you're gonna use parentheses. And so you guys can just go through this list and try a couple of them. These explanations are really good because it specifies what inputs you put in. So for example, if you guys, yeah, you can see it. So for example, if we look at insert, it calls 2 arguments. It calls the index as well as what value you want to put in. And then if you look at pop, that's going to look at only the index, not the value that you want to put in. And so a lot of these, they're obviously really helpful, and you can map them over to Snap because these functions also exist in Snap. So just to save time, I'm not going to do all of the examples, but you guys can definitely feel free to try it right now or feel free to try it later.
You appended an item?
Yeah,
Yeah.
you
You want to
append.
append a list. If you have a list and have another list, what do you have to
Oh.
Oh, okay. So that's a
Show
good
them.
question. Yeah.
Yeah.
Let's try that. Okay. So one neat thing in Python is you can use, okay. So basically we want to combine X and Y. So let's see. So if I did X plus Y, do you think that would work?
Yep.
Okay. So surprisingly in Python, that's one thing that is pretty neat about it. You can
Literally,
use,
it's English.
You can use the addition sign as kind of like a join, and it'll actually add your list together. And so that returns a new list with both of the items. So that's just one specific thing to Python. But if you did want to add it using one of the functions that we talked about, if you look at this list, there is one called extend. And it says extend the list by appending all the items in a given list. So this is different from append because append only adds one single item, whereas extend will add multiple items. So if we try that, am I doing something wrong? Okay. Okay. So now if we set X back to 1, 2. If we do X dot extend Y. So that achieves the same thing. So as you can see, there's multiple ways of doing the same thing, and some of them is just for style, or some of them is just different syntax. But it will achieve the same thing. Another thing that you can do is you can also use lists for strings. So if you want to set X equal to different words, so we can do 1, 2, 3. And then if you call item 1, that'll just return different items. And you can also use them interchangeably. So if we wanted to set X equal to 1, and then the string of 2 and 3, that would also work.
Yep, pretty simple, huh?
Yeah. And then there's one more there's another way to store data in Python, which is called dictionaries. So if we, okay, so let's start by looking at a list with other lists inside of it. So if we set X equal to, okay, let's say 1, 2, 2, 3, 3, 4. I don't think we need to get into it. Okay, so this is a list within a list, but another feature in Python is called a dictionary. And so if we want to convert this to a dictionary, we can create a new variable A and do dictionary of X. So now if we look at what A equals, the syntax is a little different. And so how dictionaries work, it basically stores data as a key and a value. So now you can access all of the values in your dictionary by calling that key. So let's say we can make this example a little more intuitive if we pretend this is an address book. So so you can use the dict of x as one way to create a dictionary, but you can also just physically write the syntax. So if we use a bracket,
Squiggly bracket. Yeah.
a squiggly bracket, so this distinguishes between a dictionary and a list. So we can say, let's say name, Karen. And then what else? Wait, no, hold on. Sorry. Name, Karen. And then let's say if I want my address. Okay, Soda Hall. And then like phone, let's just say like 408. Okay, and then we're gonna close that with a squiggly bracket.
String.
408, but is a number.
Oh, okay.
Yeah. So now if we call A, we have all these different items in the list. And you notice that it changes the order, but they're unordered lists, so the order will not matter. So when I want to call something from this list, I'm going to use the key. So if we want to look at all the keys in the list, let's look at a.keys. That's going to return all the different keys in the list. And then if we do the same thing with a.values, that's going to return all of the values. Now this is helpful if I have not just one item, but multiple items. So let's say I have the same exact thing but for Song, and the same exact thing for Samir, and the same exact thing for Andy. I can look up all of the different names, or I can look up all of the different addresses that exist and compare all of that data. So if I want to call
Yeah, you have a question?
Yeah, when you call a.keys, why is there empty brackets?
Oh, so in Python, empty brackets mean that you're calling it as a function. So if you just say a.key, it's just you're just saying, okay, I'm calling it, but without. So I'm putting it, but I'm not calling it. So if you just say a.key, it'll return.
It'll just return
as
that
a function.
object, yeah.
So it'll return it as a whole function. So you need to call the function to return its values.
Yeah. So if you look at the distinction, I did it without the brackets, and so it's just returning you that method, because that's a method. But then when you actually call it on something and you use the brackets, that'll return. It'll actually evaluate to something, basically. Yeah. Are there any other questions up to this point? Okay. Just raise your hand if you guys have questions. Feel free to stop me at any time. So now if we want to call an actual value, what we would do is we would use the same bracket syntax, but instead of calling an index like we did before with a number, we're going to call the name of that name
so we're
of
calling
the
it key, basically. Yeah.
So now if we type this in, what do you think will pop up? What do you think Python will return?
Yeah.
Yeah. And then similar if we type in address, Soda Hall. So one thing that's important to distinguish is keys are a lot of times stored as strings. So just make sure if you want to call a name, if you just typed in the name, that wouldn't return anything. Because remember in our dictionary, it's stored as a string. And right now we forgot the quotes, which is why that one didn't work.
If you do a dictionary with, say in the list, you have a item in there that has 3 items in that list, will it still work?
Yeah, so let's try that. So that's another important distinction. If we wanted to do name. So you can only have one value associated to each key. So if you typed in something like 1, 2, 3, that would error because you can only have one item, one value per string. But if you wanted to return that as a list, that list is considered one item. Yeah. So then that's one way that you could store that data. So if we do b name, that'll return one item. But if we want to look at that without the list, then you can see that will error out.
Also, a good way to think about dictionary is think of it as a real dictionary. So the key is like the word itself, and then the value is its definition. So it's exactly like a real dictionary, but it's just in Python.
Yeah.
Can I select, if I wanted to select the 2 of the list, can I select just the 2?
So if we wanted to, so then you would use that, but then you would have to operate on it similar to a list. So you can see that, let's go back to b equals name. So now if we do b name, if you want to call the to, so b of name returns that list, then you can operate on that similar to how you'd operate on a list. So now you can call the index 1 of that, and then that'll return 2.
Good question.
Yeah. And the last thing about dictionaries is changing or altering the dictionary. So if you want to add an item to a dictionary, you would just use assignment. So if we do b.name, or let's go do a.name. Okay, so if we set this equal to something, if we set this equal to song instead of Karen, and now we call A, you can see that everything is the same except the name has actually changed. And if we want to add an item, basically what this interpreter is going to do is it's going to search for the key called name inside the dictionary, and if it's already defined inside the dictionary, like I did in the earlier example, it's just going to change what the value is associated to that key. But if it looks through the dictionary and sees that that key does not exist, it's going to create a new key, and then whatever you set this equal to, so let's say school. Okay, or H, I guess that would be better. School equal to UCB.
String.
Now if we look at A, it actually created another key and value in my dictionary.
Anyone have any questions?
Yeah.
How does it organize this?
Yeah, so dictionaries are different from lists in that they're unordered. So the order will, it's always arbitrary. There's no specific.
Because you enter them in a different order.
Yeah. So it's always unordered. There's nothing that orders it. It's just always arbitrary. Yeah, since you're not going to be calling by the index, so it shouldn't matter.
I wonder how they do it.
Yeah, I'm not sure either.
Yeah.
I think it's just arbitrary.
You guys can Google that.
Yeah. But like I said, this is a lot of stuff to remember. So if at any point you are trying to work with something and you're using dictionaries or a list and you forget one of the commands, there are a lot of resources online that have compiled all of the different commands, and there's a lot of different ones out there. So remember, just feel free to use Google anytime. Google is always your best friend when it comes to programming. Yeah.
Is it possible to have library stores inside of libraries?
Libraries and stuff. Well, let's try it.
Yeah, let's try.
Stick B inside of A.
You mean a dictionary within a dictionary?
Yeah.
So, so A we already defined as a dictionary, so let's see if this works.
Yep.
Yep.
You can have anything in Python.
Yeah, the only criteria for dictionaries is there can only be one value. So as long as your dictionary is only one value, although it contains multiple values, that'll still work. If that makes sense.
So I know this is a lot to take in, as in one session.
Yeah. Does everyone feel like pretty comfortable? Do you guys feel lost? It's okay if you feel a little lost. Okay.
Yeah, so I'm gonna post this slide up, so you can always go back and review and try to do the question. If you can get the question, then that shows that you fully comprehend the materials. But this is a lot to take in one session. Just make sure that if you don't understand, make sure you understand it, and that's
Remind me again how you change an individual item in dictionary.
Okay, so the same way that you used assignment, it'll be the same exact syntax, but what Python does is it first checks if the dictionary has that key. So for example, if I did b name, then it would check if name already exists, and name already exists in my dictionary, so it'll just change that value instead of creating a new key.
Yeah, Python.
And if you actually don't understand, if you feel like you're lost, that's absolutely fine. You're supposed to feel that way. That actually means you're learning something.
This is a lot to take in one day.
If you leave this class and you're like, oh, I got it, you probably didn't get it. You should feel ambivalent. The best students always feel like, I don't know what's going on. That's when you actually know you're learning something. And then everything is screencast. It'll be on GitHub.
Yeah.
So the next, if you want to go back to it, it's just going to be like that.
And also, if you don't understand something, just Google it. It'll be there, literally.
It's there. It's not going anywhere.
Yeah, Yeah, the other thing is dictionaries is something that doesn't exist in Snap, and so when you do transition to, even when I transitioned to 61A, that was something that was completely new to me, and there's a lot of resources in 61A, and they make sure you understand it. So like once you start learning it, you won't feel as lost.
The lady in front.
So those are specifically for dictionaries. So in lists, remember we use the straight brackets, and so that just identifies that what you're creating is a list. Whereas if you use the squiggly brackets, that's just specific syntax for dictionaries. Yeah.
Would there be any difference between a dictionary that uses numbers as its keys and a list?
No, that's just two different ways. Well,
okay, so
I don't think you
that's
can
up
use
to
a
you.
list as a key.
The way you represent a dictionary is different.
Yeah.
Keys can be numbers too.
No,
though.
can be numbers.
First of all, let's note that like dictionaries are unordered inherently, whereas lists are ordered. Like everything in the list has an index. Where
Yeah.
even if you named the keys of the dictionary 1, 2, 3, 4, 5, 6, it wouldn't technically be yours.
Yeah. Wait, was your question whether you can use a list as a key or?
I think it was whether you could use the dictionary as a list.
Let's ask it.
Yeah.
The idea is that the keys are what we use to
Almost similar to index, right?
You have connected those keys, and then an index in a list is a number which sounds like it acts a lot like a key. So, I was asking was, is there a difference between dictionaries, between and I suppose maybe you answered like with the order thing, for the difference between a dictionary that had, numbers as it, 1, 2, 3, 4, 5, etc., as its keys versus a dictionary.
I guess in this case, it wouldn't matter if you just have all your keys as numbers, because as you can see, it does organize the numbers. But for strings, it's a bit different. I don't know how it would do it for strings, but for number, it does organize it in an order. Yeah, it does order it.
Yeah. And then another thing to notice is, so if you look at the example that I did right here, it takes in all different types of keys. So some of them are numbers, some of them are strings, and so it'll still return it the same way. But then in this example, something that I did was there's a key here called 1, and it's assigned to hello, the string, but there's also a key here called 1 that's assigned to 6. And so when it evaluates, what it returns is it just returns the last one that you inputted. So it assigns 1 to 6. So remember, this is just reinforcing the fact that there can only be one key for everything. There can't be two keys that are the same.
So if you call a key from A, will you get the second part of the colon as the output?
Yeah, so it'll always return the value associated to that key whenever you call the key. Yeah.
And how do you call the key?
Yeah, so let me show you. So the syntax will be similar to, so if we look at this list A, if we want to call it, we're just going to type in the name of the key. So remember in strings how we use the brackets and typed in the index?
Yeah.
So the same way, instead of typing in an index, we're just going to type in the name of that actual key. So if we type in name here, it'll evaluate. And then if we type in A of 1, it'll call 6.
So if you have an invalid key, it will just return an error.
Yeah, it'll return.
Yeah, so let's try that. Let's say age.
It'll return an error. Yeah, so because it's like it doesn't know what H is. So we should go ahead and move into like some exercise.
Yeah, I don't know how to pull it up.
Okay. I got it. Thanks. Thank you, Karen. All right, let's do some exercise. Let's just do this one for now. This checks if two lists are equal. So it returns true if it's equal and it returns false if it's not. Sorry, this is supposed to be in uppercase, by the way. True, false. Yeah. Try doing that. Take a couple minutes to do it. Alright, you guys are done? This should be easy. Alright. Define equals list 1, list 2. So what do we return? Okay. What do we return? Else? Yeah, that was. We'll get to that. So let's say list 1 equals to 1, 2, 2, 3. And list 2 is also equals to 1, 2, 3. List 1, list 2. That's true. So a short way to do this is just directly return list 1 equals to list 2. Because the expression will evaluate to a Boolean, right? So it returns false if this is not equal to this, and it returns true if this is equal to this. So that's just a shorthand to do this. Okay? So that's true. So let's say we append something into list 2. So now we say that's false. Okay? All right. Let's see what other exercise is good. Also, there's this thing called sort. This method called sort. You can just say my list. Let's say my list is this number. You can say my list dot sort. It will literally sort the list, and if you call the list again, it's sorted. So that's just for like if you want to sort a list, just call this function. But you can also write a function that sorts it, but that's a bit different, a bit more challenging. See what we already covered most of these stuff. You can multiply a list by a number, and it will return you that list twice into one list. Okay. Yeah.
What if you wanted to multiply each item of the list times 2?
We'll get to that. We'll get to that. That's a good question. We'll get to that. All right. Let's do. Should we just start off?
Yeah.
Okay. Let's start higher order functions directly from a question.
Okay, so we're all familiar with higher order functions, right? We have map, keep, and combine. And in Python, map is still called map, but keep is called filter, and combine is called reduce. They're the exact same things. They're just named differently. Right. So, okay. So let's go over the syntax of each higher order function in Python. So for map is already built in for us, or they're all built in for us, but we can use map automatically. We don't have to import it. And importing something is like saying import tools in Snap. Does that make sense? Okay, so we can start with, so let's say X is a list from,
Per question, we can multiply every single element on the list using map.
right, so so in Snap, if we wanted to multiply everything in the list by 2, what would we just use map, right? And map multiply by 2 over our list. We can do the exact same thing in Python using map. So if we have a list called X and we have map, so the syntax of map, it goes map
A function.
of our function. So if let's define a function called double, and it takes in a number, and all we do is return n times 2. Okay, so then we can say, let's say doubles equals map of double is our function, and our list is X. And then we call doubles, and we get this thing called a map object at some random place in our memory, right? But if we list doubles, we get a list output of our map return value. So it's a little like one extra step than doing this in Snap. But if you just wrap doubles in your list, it should return your list. So we multiplied 1, 2, 3, 4, and 5 by 2. Okay, our next higher order function is a filter, right? So let's say we have a list, let's say grades equals a list of scores on an exam. Let's say we have 99, 100, a 30, a 70, and say a 41 and a 75. So if we, let's say we want to define a function called define pass. What was that? Is pass already defined?
We have to hold shift and enter.
Wait, what's the issue? What? Why is that? Okay, wait. So do it again.
Oh, passes.
Yeah. So try holding shift and
Passes
enter.
do nothing.
Oh wait, pass is already a function. And it's
Okay, yeah.
Python, that's
Oh,
why.
it's a built-in.
All right, so how about,
Call it something else.
okay,
Fail.
Passive.
pass.
Passive.
He is pass.
Pass.
pass. How about let's say passed n.
Also.
And it's simply if n is greater than or equal to, let's say, 70, then we can just return true. Else return false. So we can say passed 50, and that'll tell us no, we didn't pass. That score didn't pass. So if we use, okay, so what was our list called?
Grades.
Grades. Okay, so we have grades, and if we want to use a filter, the syntax of filter goes filter, and then we have a predicate, which is our function passed, and then our list, which is grades. And that's our object. So maybe we could say passed scores equals our filter of passed and grades. And then if we list out, or actually we do have to list it out. List passed scores it filters out our grades that are greater than or equal to 70. So it behaves the same way as keep in Snap. Does anyone have questions about this? All right, so let's move on to combine, which is called reduce in Python. So reduce, we have to import. It's not readily available. So to import that, we go to from func tools, which is like import tools in Snap, import reduce. Now we have access to our function reduce. So can someone remind me what reduce or what combine does to a list? It combines everything in the list, and how many things does it return? Just a single value, right? Okay, so if we have scores, oh great, grades. Okay, we have our list of grades, and we want to see what like the total score was for the whole class. So we now have access to reduce, so we can say total equals reduce. And okay, so reduce uses it inputs a function that takes in two values. So we need to define an add function. So if we add an x and y, we just return x plus y. That's very simple. And then now we can set total equal to reduce, add, and our grades. And our total is 415. And how could we very easily just write an average function? Just divide by the length of the list grades, right? So why don't we do that? Okay, so we could write a function called average grades with a single list. And we can return, what should we return?
Total grades divided by number of grades.
Function
How would we incorporate reduce into this?
If reduce and divide by the number of
Yeah.
grades.
Right. Okay, so we can return, let's say, reduce. So we can say reduce, add, right?
Yeah.
Our list, and then divide by what? The length of our list, right? Is that all we need?
Yes.
All right, so let's check this. Average grades, and our list is grades. Cool. So remember, this includes all of our grades, right? Even the ones that didn't pass. So how can we modify this to just say, what's the average pass grade? Yeah, we could just stick in our filter into here. Stick in filter, our list,
Yes.
using our past function. So let's do that. Define average past, and it's just one input, our list, and we return reduce using add, and then our filter using past, our list. Yeah, we want to generalize because our list is our input.
There's no items.
What was that?
There's no items.
Oh, thank you. And then over the length of our list.
Extra parentheses.
Thanks.
You have to reduce the length of the list as well.
That's a good call. We do.
Yeah.
Right? Or so maybe instead we could do the length of our filter.
Yeah, the length of the filter. Yeah.
Yes. We could also set the filter thing to a variable, but we could do it explicitly like this. So the length of our filter of past and our list.
There's no
LST.
Sorry. Thanks. And that should
One more parenthesis.
work.
You just press
Okay, so this
You need to list it out first.
yeah. So our map and filter functions, they don't necessarily have a length because it's just an object. It's not really a list. It acts as a list, but it doesn't return an actual list. So we should just we need to make this a list. Wrap this in a list, and then that should work.
Well, you didn't parentheses around the length. Between
Oh, yeah.
the length and list, there has to be a parentheses.
Right.
Is that enough parentheses?
I think so. No.
Yeah, there's not enough parentheses.
So that
This
should.
is why we use a text editor, guys.
Yeah, this is why we use a text editor. So should this work?
Better work, yeah.
Okay.
There you go.
So our average pass grades are 86. So for your challenge problem for next week.
I think it's in the slide.
Your challenge problem for this week is this here. And we also want to give you a challenge using strings that is the same problem that you used in lab, and it's called acronyms. So it should return the acronyms of like University of California, Berkeley.
Like
it should
what?
return UCB
Like
in
what
all
Dan did
caps.
in lecture, he use map, keep, and combine to so you have a string and then it returns its acronym using map, keep, and combine in lecture.
Let's give these guys a round of applause for teaching this. So just like before, we really want to get your feedback for next time because we will iterate on it on a weekly basis. But before I pull up the server here, I'm going to have Emoji just do a quick sneak peek of what you're going to be learning next week, and then I'll have some closing announcements after.
All right, so next week is very, very important. Next week is when we move into Python. Next week is when we start making you a professional beginner. Right now, the first two sessions has been going from Snap to Python. Next week, we're going to talk about data modeling. And data modeling is what you really need to build your web apps. So everybody has shopped at Amazon, right? Have you ever wondered how it's powered? Like, what is the back end of Amazon?
Yeah.
Yeah, right? You thought about it. They have to store all their data in one way or the other. Well, next week, you guys are going to learn how to do something similar to that. And 2 weeks from now, you would have built your own web app with a complete backend, and you'll be pushing it to Heroku. And then you can show up to everybody like, oh, I built this web app. I'm so awesome. Yay.
You guys excited?
And then you can go get an internship and
I'm
make
excited.
lots of money.
I'm going to learn it.
So on and so forth. But it's so awesome. And this is the part where, for a lot of people, back-end programming sometimes seems challenging. But this is the part that is actually the most intuitive. Because everybody has a way of reasoning about data. And your way of reasoning about data is absolutely valid. And it's more of a collaboration. So I think about things a certain way, Samir thinks about things a certain way. We put down our thoughts together on paper, we compare it, the things that match, we stick to it. The things that don't match, we push them out. And then we ask questions about our data. Will it support this? Will it support that? Once we figured out all that kind of reasoning, then we'll build the backend, we'll do a data model, we'll build it out in Python. And so even the dicts that you saw today in the Python, the dictionaries, very, very similar to what you're going to do in building a backend. You're just going to make it much more elaborate, and then hopefully at some point connect it to like a database in SQL or something. And like magic, boom, it's fun. So come next week, Thursday. It's going to be super exciting. I'm excited.
Tell your friends because...
Cool, and for those of you guys that put your laptops away, can you please bring that back out? We do have a quick survey for your exit out of here. So if you can go to tinyurl.com/beyondblocks2.
Beyondblocks2.
Yeah, so we've changed the questions up a little bit. And I also want to apologize for this comedy show that I promised you guys at the beginning because I didn't know that what he was planning. So if you scroll all the way down to the bottom of the survey, we are going to iterate on that as well. So you can say how funny was songs from 1 to 3. And had to get you back. And if it's not exactly 3, then we'll have something else next week. Because I mean, if I was involved, then it would have been fun.
Come on,
right?
guys.
So.
You guys got this.
Cool. So please fill this out on your way out, and then also in the one sentence, like that could just be anything. It's not going to be tied back to you because it doesn't have your name. So anything that could have been better here, please let us know. Cool. Any closing thoughts? Oh, and how many of you guys are planning to do the competition?
All right, so get your GitHub account. Oh,
Yeah.
There's a fun GitHub video. Like why GitHub is awesome. They made this super awesome video. Maybe I'll put it up on the GitHub webpage. That's fun. So you should learn Git, push your solutions on GitHub, and just geek out. Have fun with your Project Euler.
And if
don't cheat.
Yep.
Think about it. Solve it first before you go Google the answer.
Yeah, and if all this makes no sense to you, like pushing it to Git, that's why we advise that we're going to have a Piazza post put up like later tonight about the competition. But literally when you create a GitHub login account, there's going to be options to do tutorial. And if not, just Google GitHub tutorial because it'll make it really easy for you to upload all your stuff. People have been using GitHub for outside of code too, like with pictures, essays. It's like the new version control for like everything. So we want you guys to start getting used to it.
And after Beyond Box, you could potentially go work at Git next summer. You have enough stuff on your Git repo for them to see that you actually are competent and you could extend it.
A lot of tech companies now don't even ask for your resume. They'll just be like, can we have
Show
your
me your
GitHub link? And some don't even care about GPA. They want to see what you've built. And we'll go more over that in a future discussion in CS10 when we talk about getting involved in CS. So if there's anything you want to learn more about that, just put that in that one sentence area. You could just say, I want to learn more about this. Cool. Thanks, guys.
Thanks.